Hello and welcome to zwitterstat. In this video, we are going to continue with our discussion on matrices, and in this lecture, we are going to discuss about the types of matrices. So, the first type of matrix that we are going to discuss is a rectangular matrix. So, a rectangular matrix is a kind of matrix in which the number of rows, that is m, is not equal to the number of columns, that is n. So, for example, we have a matrix having elements 1, 3, 5 in its first row and 2, 4, 6 in its second row. So, we can clearly see we have three columns: first column, second column, and third column, right? And we have two rows: first row, second row, right? So, the number of rows is 2 and the number of columns is 3. So, such a matrix is called a rectangular matrix. And another reason why we call it a rectangular matrix from its shape, right? Look at the shape. It forms a rectangle, right? That's why we call such a matrix as a rectangular matrix, because the elements in such a matrix are arranged in such a way that it look like a rectangle, right? So the next kind of matrix is a square matrix. Now, square matrix can be thought of as a special kind of rectangular matrix in which the number of rows is equals to the number of columns. So a square matrix is a special kind of matrix in which the number of rows is equals to number of columns. So for example, we have a matrix in which there are elements 1 and 3 in the first row and 2 and 4 in the second row, right? So we have two rows, these are two rows, and this are the two columns, right? So we call such a matrix as a square matrix where the number of rows is equals to the number of columns. Here m equals to 2 and n equals to 2, right? Now the third kind of matrix is the row matrix, often called as the row vector, right? As I have said in my previous video that when we will study about the vectors in our further lectures, then we will look at more deeply about row vectors and column vectors, right? And why such a representation is called a row vector and a column vector. We will clearly look at in our lectures in vectors, right? So, a row matrix is a matrix, or row vector is a vector, or a row matrix in which we have one row. We have one row, right? So here is an example of one row and three column, that is 1 2 3. This is a row matrix or a row vector. Here our number of rows is 1, right? So any matrix which has a single row is a row matrix or a row vector, and the number of columns can have any value. It may be 3 as given in this case, and it may be any value, right? So this is a general representation of a row matrix, a1 a2 and so on till an, where n can be any value, right? Any positive integral value. Similarly, for column matrix, a column matrix is a matrix or a column vector having one column. So for example, we have one column over here, and the number of rows, it can be any, it can have any value. Just like look at this general representation, right? a1 a2 an, these are the different elements in the first column, and the number of column is always 1 for a column matrix, and the number of rows can have any value, where n where m can be any positive value, right? So moving on with our discussion of types of matrices, here we have a fifth matrix which is called the diagonal matrix. So a diagonal matrix is a matrix in which we have non-zero diagonal elements, our all the elements in the principal leading diagonal, this is called the principal leading diagonal, and the elements in the principal leading diagonal is not 0, and all the other elements are 0, right? So our all other elements are 0. These elements, these elements are 0, right? So such a matrix is called a diagonal matrix, and one thing that we have to take care, or we have to note, that a diagonal matrix has to be a square matrix. So m equals to n condition must be satisfied, that the number of rows must be equal to the number of columns, right? So a diagonal matrix is a square matrix in which we have non-zero elements in the principal leading diagonal, and all other elements apart from the principal leading diagonal are 0, right? So this is a general representation, the matrix A, and its elements are, this is a general representation of the matrix Aij, where Ij represents the position of the element in the matrix. I is the ith column and j is the jth row. So for I equals to j, when the when the row number and the column number are same, that is, we are talking about the elements in the principal leading diagonal. So it will be non-zero, that is aii, that is a non-zero element. And for I not equal to j, for all other elements apart except the principal leading diagonal, that are 0. So we have written a general representation for it, right? And this is the general representation for our matrix, right? So talking about the zero matrix, so zero matrix is a matrix in which all the elements in the matrix are 0. So it may be a square matrix, it may be a rectangular matrix. So all the elements in that matrix is 0, and such a matrix is what we call as zero matrix. Similarly, we have a unity matrix. So unity matrix is a square matrix, right? So unitary matrix is a square matrix, right? So unity matrix is a square matrix in which the principal leading diagonal elements are all 1. So we have 1 in our 1 in the as the elements in the principal leading diagonal, and all other elements are 0. So it is a 2 cross 2 unity matrix, and this is a 3 cross 3 unity matrix, right? 3 rows, 3 columns, and 1 as element in the principal leading diagonal, right? And all other elements are 0, right? So now we are discussing about addition of matrices. So two matrices are added only if both the matrices have the same dimension. Just like in our case, we are having two square matrices of dimension 2 cross 2, that is, each of them is having two rows and two columns. So they can be easily added, right? If they don't have the same number of dimensions, then they cannot be added, and we must take care about it. So the first thing that we have to keep in our mind is to check the dimension of both the matrices. If they are same, then we can add the matrices, and if not, we cannot add them. So for example, we are having two matrices A and B, and they are having the same dimension, that is 2 cross 2, two rows and two columns. So we add them by adding the elements, the respective elements which are at the same position in both the matrices. So 1 is added to 5, 3 is added to 6, 2 is added to 7, 4 is added to 8. So when we perform the addition, we get 6, 9, 9, 12 as the resultant matrix when a matrix A is added to matrix B, right? Similarly, we perform the subtraction. Subtraction similarly is also, while performing the subtraction of two matrices, we must take care that both the matrices have the same dimensions, right? So, and the subtraction is performed by, we need to subtract the elements which are at the same position from one another. So if we are performing a minus b, then 3 must be subtracted, then 2 must be subtracted from 3, 3 must be subtracted from 5, 1 must be subtracted from 7, and 7 must be subtracted from 9. So on performing the subtraction, we get the required result, that is 1262, right? Now we are going to perform and study about the multiplication of a matrix by a scalar. So scalar is nothing but a number, right? Scalar is nothing but a number. Scalar is a number. So it may be 2, 3, or any other number, right? No matter, any real number we can thought of as a scalar. So when we when we multiply a matrix by a scalar, it means we multiply all the individual elements of that matrix by that scalar. So let's say we are having a general representation of matrix A is equals to Aij, and it has dimension m cross m. So when we multiply lambda is a scalar, to a matrix A, we means the scalar lambda is multiplied to each and every element of that matrix. M cross n is the dimension of that matrix. So let's say we are having a 2 cross 2 matrix, 1, 2, 3, 4, and we say we have a scalar lambda equals 2. So when we say we are multiplying 2 to that matrix, it means 2 into 1, 2 into 2, 2 into 3, and 2 into 4. All the four elements of that matrix gets multiplied by that scalar 2. So we get 2, 4, 6, 8 as the resultant matrix after multiplication by that scalar, right? So in this video we have discussed about multiplication of matrices by a scalar, subtraction of matrices, addition of matrices, and 7 different types of matrices. And I hope you have get the idea about what are the different types of matrices and what are and how we perform addition, subtraction, and multiplication of a matrix by a scalar, right? So in the future videos we are going to discuss more on matrices, and we will perform numerous problems on matrices, right? So stay tuned. Thank you.